Okay, so there's two more functions in this OCaml sequence module that I'm not going to do in this video. They're relatively straightforward. Well, fold left is a little crazy, but I'm just going to move on. This could be fun to implement as well, but I just want to sort of show you the refactoring I was able to do once I had this sequence. And it was surprisingly simple to replace the list that my function was returning for a sequence. So I just want to show you a little bit about that refactor. So I was sort of writing like a prologue implementation, like a really simple one, just for fun. And I had this place where I'm solving, I need to sort of solve a query, answer a query given like a knowledge base, a sequence of facts, or actually a list of facts. And I had been using this function called keepMap. And keepMap is, I'm not sure why they call it that, but it's essentially a filter map. So my unify function here returns like an optional thing, and I'm going through each fact in the knowledge base and trying to unify with that fact, and then only keeping the results that are some instead of none. And it turned out that really all I had to do to replace this with a lazy sequence was pretty much just change that belt list keep map over to a sequence filter map, and then transform my knowledge base, which is a list of facts, into a sequence. So there was like barely anything I had to change, and then I got sort of like streaming capabilities, and it solved a whole bunch of problems. And then another place where I was able to use this sequence was when I'm solving a list of, when I'm solving sort of an AND query where there's several queries ANDed together. So it'd be like, is this thing true, and this thing is true, and this thing is true. So, in that case, I was using utils.flatmap, which is something I wrote, which works on lists, so it's the list version of flatmap. And really all I had to do there was just change this to seq flatmap, and everything worked. So it was really easy to refactor. There was more things I needed to, there were more things I needed to change because my type signatures were changing, but this was like the core of the refactoring, and it went really smoothly. So I was just really happy about that. The last thing I want to just say is people might be, there's a lot of recursion in the definitions in our ReasonML seek module. So I just want to show that it is like a different way of doing recursion than normal. So oftentimes you need to be careful of recursion because you could blow out the stack. But with this kind, I believe it's actually safe. So here's a demonstration in Python. So I have this function natseek, which is sort of going to return like an infinite iterator, an infinite sequence. And I'm representing, like our node of tick A object in OCaml or in Reason. We just have a tuple which contains the number and then a function that gets you to the next value in the sequence. And it recursively, semi-recursively calls itself. And then I have this function which is actually going to use that iterator. So it's just going to go into a while loop and kind of keep pulling things out and printing them. And then I've also written this in a straight up recursive way. So this is sort of like, the factorial recursive function that you always write when you're learning recursion. It just directly calls itself with x plus 1. And if I run these two, I can call, let's call the recursive function first. So this is the last one I showed. And if I run that, I run into the recursion error. It says I've run out of stack space. It printed out up until 995. I'm not sure why that many, why it failed after that many, but that's the maximum we could get there. But if I do the use natSequence function, which is going to use the other one, this actually just keeps going. So this makes me believe that this way of like iterating lazily sort of escapes the breaking the stack problem that a lot of recursive algorithms have. So that's pretty cool. It says that like you can kind of just keep iterating if you want. We're already up to whatever, is that 2 million or something? Yeah, so I think this is a pretty viable and efficient way to do iteration. And finally, I just want to mention that I have the code that I wrote originally to solve this problem up on GitHub. I'll link to it in the description of this video, and you can see how I did it. It's almost identical. I just renamed a couple variables here and there. And there are implementations of the iter and fold left functions down at the bottom too. So yeah, thanks for watching, and bye.